So how should you use the U-substitution of integration? And basically using the log rule of integration. How should you be able to go over that? Let's say we have a function. Let's say f of u is given as, let's say, 1 over u. Now, what is the integral of 1 over u du? So in this case, according to the principle behind the the integral is given as ring of reciprocal of u plus c. Now this is the formula. So how should we have to accomplish this one? So let's be together. Let's say we are to evaluate the integral, let's say of 5 over x dx. So how should we be able to integrate this function if that's the case? So in this case, we'll have to let the denominator be equal to u. So in this case, we'll have u is equal to x. And what is the du? We'll have it as 1 actually. So it should be 1 dx. So what will be the dx? So now the dx is given as actually du. Then we have to substitute for dx actually for du where there is x, and we have to we'll have to substitute actually du where there is dx, and also where there is x put du. So which means we'll have the integral of 1 over u and actually du. So now, what is the integral of reciprocal of u? Now, which according to the log rule, we'll have it as the ln u and the plus c, of which we'll have it as ln, what is the value for, we'll have it as x and the plus c. Now this is the integral. Now what if we have this case? And this is only been done if we have the function which is in reciprocal nature, the one with 1 over the variable that we are actually integrating with respect to. And the rest have to come across this case as well. You should have to appreciate what it means. Let's say we have the integral of 1 over x plus 5 dx. So what is the integral of this function? So now according to the principle, we'll have to write the denominator be equal to u. So in this case, we'll have u is equal to x plus 5. And what is the du? We'll have it as 1 dx, because we are differentiating with respect to x, so we'll have dx at the end. So in that case, we'll make dx as the subject, hence we'll have dx is equal to u. Then we have to substitute for u as well as the dx. So now have the integral of 1 over u times du, and of which we have it as now the ln of u plus c, where c is the constant of integration, as you can remember. So now which means we'll have it as ln x plus 5 like that, and the plus c. Now this is the solution. And what if we have this case? Let's say we have actually the integral of, let's say, x over, let's say, x to the power 2 plus 3 and dx. How should you have the integral of this actual expression in this case? So now principle remains the same. We're going to use the U-substitution, the way I will have u being given as x squared plus 3. And what is the du? We'll have it as 2x and times dx. Then what is the dx? Now the dx will be given as the du over 2x. Then I'll have to substitute in the sense that we'll have it as the integral of x over u times dx, that is given as the du over 2x. In this case, we'll have x and x being cancelled. So in that case, we'll have the integral of 1 over 2 and 1 over u du. So what is the integral of 1 over 2? We'll have half ln of u plus c. In that case, we'll have it as a half ln of, now should be x squared plus 3 in the plus c. So that is the solution in the for that case. So that's the principle behind the U-substitution, and applying the concept of the log of integration. And I think about this one as well. Let's say we have, let's say, x squared, that should be that plus 2x and plus 3. That is the integral rather divided by. And of course, we should have to go through this one. Let's say the integral of now should be xx plus 2 and divide by, let's say, x cubed and plus 3x squared. Let's say that's the case, and minus 4. So what is the integral of this function? So now the first thing is to actually re-express the expression in the sense that we'll have the integral of, then we'll have to expand that one. That will be given as, now should be x squared and plus 2x divided by x cubed plus 3x squared minus 4, and I should have dx at the end there. So that is, then using the U-substitution, we can have it as u being given as x cubed and plus 3x squared minus 4. What is the du? We'll have it as a 3x squared and plus 6x, and the other end there we'll have it as the dx, and they make dx as the subject. We'll have it as, now should be du over 3x squared plus, now should be 6x. So that is, then I'll have to substitute into the expression in the sense that we'll have the integral of x squared plus 2x divided by, now we'll have to now divide by u, so that is times, now should be du over, now we'll have to factor out x, that should be 3 rather, we'll have to factor out 3. In that case we'll have it as a 3, that should be x squared, now it should be that it should be what, so we just have to simply leave it like that. We don't need to factor out that one. So in this case we'll have it as 3x squared plus 6x in that way. So we need to factor out 3, as I already suggested about that one before. So in this case we'll have to factor out as 3, so that we'll have to cancel this, and we're going to have it there. And of course, let me just have to have it being factored. So have 3 x squared plus 2x, like that. Then we'll have this being cancelled, and thereafter we'll have this case. Let's say we have the integral of 1 over u times 1 over 3 du. If that's the case, then we'll have it as 1 over 3 integral of 1 over u du. Now you can be able to proceed it from there. So take note of that. Now what if we have this case? Let's say we have the integral of ln x and over the part 2 divided by, let's say, x dx. So what is the integral of this expression? So in this case we'll have our u being given as the ln x, and what is the du? We'll have it as 1 over x, then dx. then I should have to make dx as the subject, in the sense that we'll have dx is equal to x du. Then I will have to substitute, or have it as the integral of, now should be u square and over x times, now should be du, actually it should be what, x d, actually du. So have it as the x du over, in this case we'll have this one being cancelled, then we'll have the integral of u square du. So what is the integral of u square? We'll have it as being given as the u to the power 2 plus 1 over 2 plus 1 in plus c. So you can take it from there. You just have to substitute the expression in which the u was representing. Now what if we have this case? Let's say we have a case like this. Let's say we have integral of 2x and x minus 1 to the power, let's say 2 dx. So basically the expression which is inside the square root, or which is inside the power, it is the one that is basically given as the actual u. And basically that's the principle behind. So in this case we'll have the u being given as x minus 1. What is the du? We'll have it as, now should be 1 dx, and of which dx is given as the du in that case. Then we'll have to substitute, we'll have the integral of 2x and over, should be u square now times du in that case. So now as you can see that we have not managed to cancel that x on top there. Then we use what we call changing of the variable, where now we'll have to come to the point where we said u is equal to x plus, so actually x minus 1. Then we'll have to make x as the subject, in the sense that we have it as x is equal to u plus 1. So in that case we'll have to substitute where there is x, put u plus 1. Now that is onto here. So now we'll have it as the, so that's what you call the changing of the variable. So now have the integral of 2 times u plus 1 and that divided by the u square and that times du in that case. So which means we'll have the integral of 2u plus, now should be 2 over u square du, and of course that is, then I will have to move it from there using the concept behind the algebra, in the sense that we'll have it as, and mind you we have plus 2 here, that should be what, oh yes, we are here. So now it means we'll have it as the integral of, now should be 2u over u square and that plus 2 over u square in that case. So in the outside we'll have du there, so in that case we'll have it as a du. So having this one, then this is the same as having it as the integral of, now should be 2 over u, that should be that plus, now we'll have it as 2u to the power negative 2, and we'll have du. So what is the integral of this one? Now use the log rule, that will be given as, I'll have 2 renew, and I'll have it as a plus 2 u to the power negative 2 plus 1 over negative 2 plus 1 in plus c. Now you can be able to finish it off in that case. So that's the principle behind the changing of the variable, and whenever the cancellation is not working for actually that manner. So take note of that. And what if we have this case? Let's say we have this kind of a problem, in the sense that we have, let's say we have the integral of x. Now of x in the open bracket in the x minus 2, and that should be divided by, let's say, 1 minus x to the power 3. Let's say that is the case in the dx. So what is the integral of this expression? And of course we just have to expand there, in the sense that we have the integral of, now should be x squared and the minus 2x, which is divided by 1 minus x and over the power 3 and that of dx. So now for this case we have the u being given as 1 minus x, and what is the du? We'll have it as, now should be somewhat about negative dx, and of which dx will be given as the negative du in that order. Then let's think of substituting that on. So in this case we'll have it as this. We'll have the integral of, now should be x squared minus 2x divided by u to the power 3, should be u to the power 3 and times the negative du, and of which this is the same as negative integral of x squared minus 2x and of u to the power 3. So that's the principle behind. Now you can see that we have not yet removed the actually x there, so it means we'll have to use the principle of the changing of the variable, in the sense that we'll have to make x as the subject here, then we'll have to substitute it here and be able to have the solution. So try to have that at your own time, that is. And also let's think about this problem as well. We should have to see the way you can have to take it out in that case. Let's say we have the integral of, and that should be 1 over, let's say, the square of x plus 1 dx. Now should be this. Let me present it properly. Should be this, actually should be given as 1 over now the square of x, so should be 1 plus the square of, now should be 2x in that case, in that dx. So what is the integral of this function if this is the case? So now we'll have our u being given as 1 plus now the square of 2x, and of which this is the same as 1 plus now 2 to the power half and x to the power, let's say, half, so that is the same as that. So what is the actually du of the case? So which means we'll have it as now the square of 2, because the 2 is like a multiple constant, then we'll have to differentiate the x, and of which we'll have it as, now should be half x to the power negative half in that dx there, and of which this is the same as having it as, so now the square of 2 over 2 and that x to the power now negative half, so to the power negative half dx, and of which, using the laws of indices, that is the same as having as du is equal to now 2 to the power half minus 1 and now 1 over the square of x and dx there. That is the same as that. That is upon using the laws of indices. We can have it as that. So which means the further simplification will give us du is equal to, now what is half minus 1? We'll have it as 2 to the power negative half and divided by square of x dx. Now that is the way to go, of which this is the same as Now we'll have it as 1 over square root of 2 and it times x dx. So in this case it means that dx will be given as now a square root of 2x, then now we'll have a du. So that is the dx in that case. Then now we should have to substitute as far as the U-substitution is concerned, in the sense that we have the integral of 1 over u times. Now what is dx? We have it as should be the square of 2x times du. Now as you can see, we have not yet managed to cancel out the variable as x. So we use the same principle behind the change of the changing of the variable, and to express the x in terms of u from the way we discussed it before. So try to have this one out at your own time in that case. And what if we have this case? Let's say we have the integral of now should be the cube root of x, and that divided by, let's say, the cube root of should be x minus 1 in that case, dx. So what is the integral of this one? Try to express that one and at your own time. And let's say we have, in this case, let's say the integral of 1 over 1 plus now should be the square root of 3x dx. What is the integral of actually that kind of a problem? You should also have to try that one at your own times. And also think about this one as well. What if we have the integral of 10 over x squared? That should be 10 over x dx. So what is the integral of this function? So you can also be able to have that one out at your own actually time. You also should have to try this one as well. Let's say we have the integral of, let's say x minus 1 over x plus 1. Let's say that's the case. What is the integral of that one? You should also have to try that one out as well. And what if it is actually a definite integral? You should have it from 0 to, let's say, 3. So it should be 0 to 1 another. You should have that one. And what if we divide the integral from, let's say, 0 to 2, and that is x squared minus 2 over, let's say, x plus 1 dx. So try to have these kind of definite integrals, but using the same principle. And I also should have to try this one as well, and get it up to, let's say we have the integral of 1 minus the square root of x, and of 1 plus the square root of x dx. So try to have the integral of this expression as well. That is in that case. So that's how you have to understand about actually the U-substitution using the log law, and also the concept behind the changing of the variable as one of the techniques behind the techniques actually as one of the techniques used actually behind the U-substitution in that case. Thank you.